I want you to be careful because for these first four, you'll get something looking like this, and they'll say which one gives the equivalent of this answer. So you're going to need to make sure not only are you showing work for each one, but then you're circling the correct answer. So as soon as I see to the 1/3 power, I'm thinking, what can I take to the 3rd power? Well, I know the rule for the 3 zeros is 10 to the 3rd to the 1/3. That cancels. That's 10. No plus or minus. While I want to focus on the 5, I care more about the 2 because that's what makes it a fraction, and that's what I want to be gone. So I'm going to go 10 squared to the 5/2. The squared is gone. I'm left with 10 to the 5th, which is a 1 with 1, 2, 3, 4, 5 zeros, plus or minus. But I will tell you that if the test says which one is equivalent to 100,000, you will circle that answer because that is a possible answer. All right? Let's look at the next one. This looks like 10 cubed squared to the 1/3. Notice I'm showing my work. You need to show your work because honestly, you're allowed to use the blue calculator. And if you just took the blue calculator and you plug that in, which is something you can do, you can go let's see, you go 3 cube root of 1,000 squared, and it's going to tell you it's 100. You can't just give me 100, but you know the answer is 100. So how do you show that? The 3's are gone, 10 squared, and that's why it's 100. So if you just circle the answer because you say it's equivalent and there's no work, you're going to lose a point. The next one is a 10 with 1, 2, 3, 4 zeros to the 1/4. Boom, it's 10, plus or minus. But if one of the options is which one is equivalent to 10, that would be included as an answer. Okay. Let's go to the next one. I'm definitely more of an exponential girl, and so I would definitely like to rewrite it that way. And this is negative x to the 10th to the 1/5. These cancel out. And this is really negative 1 to the 1/5 and x to the 10th to the 1/5. I want you to be careful of that. Let me move it over a little bit. Sorry about that. So if I go negative 1 to the 5th to the 1/5, it stays negative. Or when it's an odd root, it stays negative. So I'm sorry, let me go back to the top. 2 to the 5th to the 1/5 is 2 on top. Then here, there's the negative stays. That turns into a 2, x squared. But you know I don't like a negative on the bottom, so it's negative 2 over x squared. And I don't care right now about telling me the restrictions. That's not what this is about. It's about simplifying the exponents. Okay. Let's look at the next one. They have the same root, so I can just add the exponents. There are different ways to approach this. One way to approach this is doing piles of 4. So I could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So I circled 4 piles, and I'm still left with 3 of them. And it's the 4th root, plus or minus. Another way that I could do this problem is I could rewrite this as x to the 16th to the 1/4 and x to the 3rd to the 1/4. Or this gives me x to the 4th, but because this is a fraction, it's the 4th root of x cubed, plus or minus. It doesn't matter how you get the answer. Just make sure you get it. All right. This next one is asking to figure out the cube root of 125 4 different ways. Well, I already got one way. Let's do another way. 125 is the same as 5 cubed. I can rewrite this as 5 cubed to the 1/3. I could tell you the answer is 5. I could rewrite this rad form in exponential form, 125 to the 1/3. You get the idea. I can't do any minus now because this is a cube root. If it was a square root, I could have done negative 5, but it's not. I want to be clear on these next ones because on these next ones, you have to prove equality. So you can't give me 2 to the 10th equals 4 to the 5th. That's not the same thing. If you're doing a base of 2, this needs to have a base of 2. So I feel like this is kind of messy. So I'm going to rewrite it. This looks pretty clean. So I'm going to try to see if I can get this to be 2 to the 10th. Well, I know 16, I shouldn't go 4 squared because that's a 2. I know 16 is 2 to the 4th. But then it's to the 9th. But then it's to the 1/3. And now 9 goes into 3 times. 2 to the 12th does not equal 2 to the 10th. So it's false. That's how you are showing me equality. Okay? I can't just write the square root of 4 as 2. I need to go 2 squared to the 1/2, and that tells me the right side. Be very clear about that. 8 is the same thing as 2 cubed to the 1/3. Boom, it equals 2. I understand that this side is positive and this side is plus or minus. So while it's true sometimes, it's not true all the time. So that would be false also, because this one only has one possible answer and this one has 2. Okay. Playing the 2 game again. I don't really know what to do with that. So I'm just going to make this the same as 2 cubed. Remember, square root means 1/2. So this is 2 to the 5/3 equals 2 to the 3/2, and those are not equal. All of these end up being false. But you notice, what I need you to get every single time is that the bases are the same. Not they all happen to be 2. That's a really bad example to do. But I need you to just get that the bases have to be the same from one to the next, and one to the next, and one to the next. Let's look at this in exponential form. All I want you to do is change it to exponential and see if you can simplify it. I don't know what to do with 20 right now. So I'll rewrite it as 20 to the 30th power to the 1/10. Now I will say you could have written it like this. You could have gone 20 to the 1/10 to the 30th. It's the same thing. I don't care. Because either way that turns into a 3. Either way that turns into a 3. So 20 to the 3rd, which might seem like it's difficult, it's not. Because 2 to the 3rd means 2 times 2 times 2, 8, 3 zeros. Okay? Now since it's taken to an even root, plus or minus. Okay. Let's try the next one. Since it is the cube root, I have to focus on getting something to the 3rd power. So it's -6 cubed to the 2/3. If you didn't know that, what you're going to do in your calculator is you're going to do this. 5 times 5 times 5. Too low because I need 216. 6 times 6 times 6. Cool, there's my 216, but it's negative. This is gone. I'm left with -6 squared staying in parentheses, and that's 36. It's an odd root, so it stays. Okay. There's different ways to approach this, but since they both have the same root, I'm actually going to combine them and put the 13 on top and put the 5 on the bottom. And I know that when I subtract exponents, when I divide exponents, it really means I subtract, or I'm the type of person that goes more on top or bottom, and there's more on top by 8. Let me move that over. So I have different ways to approach this. I can approach it the pile method. I'm trying to get piles of 6. 1, 2, 3, 4, 5, 6, 7, 8. So I have one pile, x, and I have 2 left over, 6th root, plus or minus because it's even. I could also rewrite this as x to the 6th to the 1/6, and x to the squared to the 1/6. 6 over 6, that gives me the 1. 2 over 6, and technically I guess I should write that as 1/3, shouldn't I? Okay. So if that ends up happening, I'll give bonus if you rewrite this as plus or minus x cube root of x, because that's actually more simplified. But if you leave it like that, I'm fine. I don't even know what you're going to see. You'll see one or the other. Okay. Let's go to the next one. These ones are a little bit more complex, so I'm going to go a little bit more slowly. I'm not even going to look at the 11. I'm going to focus on the 98. I know 98 is even, so in my calculator, 7, 7, there's my double. So my double goes on the outside, but then I have this other double, so I multiply those two together. I'm sorry, it's not a double. I have this on the outside. So it's -77. Keep my square root. I didn't use my 2, so that's what'll go in the inside. I can't do plus or minus because it's telling me it's negative. Now I'm going to go through the A's. I know since it's square root, I'm looking for piles of 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. A to the 5th. The B's, 1, 2, 3, 4, 5. So 2 piles for B's, but there's 1 left over if you see that. That's what's going to go here. And then with the C, I only have 1 C, so that's what's left over. Boom. I'm done. It's okay if you do the pile method. If you want to do something different, if you want to go a to the 10th to the 1/2, so if you want to do it in exponential form and go a to the 10th to the 1/2, a to the 5th. If you want to go b to the 4th to the 1/2, which is b squared, and then you're left with a b, sorry you can't see that, that's fine too. If you want to go c to the 1/2 and there's nothing left over, and that's why the c is on the inside, fine. If you have no idea what I'm saying, don't worry about it. Pile method works every time, if you know how to do the pile method. Okay? Let's go to the next one, 32. If I'm doing 32, 16, 2, 4, 4, 2, 2, 2, 2. But I need you to be careful because this time we're going for piles of 3. So 1, 2, 3 goes on the outside. I'm going to leave some space here, do a cube root, but I'm still left with this 2 and this 2. And 2 times 2 is 4. So that took care of the numbers. Done. For the x's, piles of 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 3 piles, nothing left over. If you want to write it as x to the 9th to the 1/3, there's x cubed. You could mix and match. So for the 32, you could do the pile method, but for the 9, since it goes in perfectly, you can do the exponential method. I don't care. For the y's, piles of 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 1, 2, 3, 4, 5 y's, and then I'm left with 2 of them, so that's y squared. No plus or minus because it's cube root. If you want to rewrite y to the 17th as y to the 15th to the 1/3, and y squared to the 1/3, and there's your 5, that's fine. And that, I don't care. Just get there by showing work. Last one of the page. So the thing that I have a problem with on this one is, well, actually I don't have a problem yet. First thing I'm going to do is look at the x's, and when I'm multiplying, it means I'm adding. Now I'm going to take care of the y's. There's an imaginary 1. And 7/3 plus 1. 1 is like 3/3. So that's 10/3. Okay. Now what I'm going to do is, the only thing I don't like is that this negative is on top. This is fine because this is a number. So I'm going to bring it downstairs. And I'm done. I want to put a caveat on this. What happens if I instead, let's just pretend that I ended up with -9 over x cubed y to the 1/5. Let's just pretend, okay? Now, I would be okay with this and I'm okay with this, but I'm not okay with this. So what could I do to change that? Think of money, think of $1. Like you can't have cents on the bottom, you can only have $1 on the bottom. So I would literally put $1 on the bottom. So 1/5 happens to be 20 cents. So I have 20 cents more on the bottom, which means I have 80 cents on top. Or 1 minus 4/5 is 1/5. Or 1/5 plus what will give me $1. Okay? So keep in mind, this is the caveat. You can have a fraction on top, but if you ended up with a problem where the fraction was on bottom, you can't have cents on the bottom, so you need to make it $1.